has to decide that what is the current temperature, what is the set temperature, how many minutes am I left with the timer, and that's the output that it is also giving, right? So based on some logic it's giving the output as to should it heat the induction coil, should it stop heating, and so on. So, and I'm also just creating some notes here so that it's easier for you. Let me just increase the font size. So the basic paradigm we're going to be following is take input from user, do some useful processing, give some output. Right, so this is the main paradigm that we'll be following in all our programs. Start. I think I'm getting a bit of echo. Can you just take it up close and it's muted and the speaker is off? Okay, I think it's okay now. Just muted it. All right. So let's open a replet. Let me just create a new replet. Let me just call it 28 November 2022. So we've said that we want to be doing three main things: take input from the user, do some useful processing, give some output. Let's first focus on giving some output to the user. So what function did we study previously which can be used to give some output to the user or printing something to the console? Print function, right? So the way it works is I write this keyword in Python, print, and whatever I want to print or whatever I want to display to the user. So this is something I want to be printed. This is the name of the function that I have. I go to my shell, I type python main.py, and if you see, this is what gets printed. This is something what you want to print to the console. So I'm also just copy pasting code in this format. So this is known as a Jupyter notebook. Some of you might have already seen it. The advantage of Jupyter notebook is that when I'm finished with the entire session, you get a single notebook like structure where you can copy paste code from rather than having to go through multiple replet code, right? So we can print like this. We could have also printed some integer number, which is, let's say 10, a floating point number, which is a decimal number with the decimal digits, 10.5. If I run this program again, in 3 different lines, I get what I wanted to print the first line. So this, whatever was within the double quotes, gets printed here. Whatever is the argument here. So the important thing is that the input to these print functions is different for each of the 3 lines of code that we have. Here it's a string of characters, right? It's a string object. Here we have an integer which we're trying to print, and here we have a floating number that we're trying to print, right? So irrespective of the condition that we're printing, of the type we're printing, these are printed to the console. Any questions thus far? Right, so thus far the programs are only limitedly useful because we are just directly printing out some things. Yeah? But we may also want to do some some useful manipulation. So which is do some useful processing. But in order to be able to do some useful processing, we need to be able to store the contents somewhere, right? So if you remember in the previous class, we discussed that we can use something known as a variable to store certain values, right? Variable to store certain values. We said that we can have a box of sugar, right? It's just a box, but you can put a label around that and call it sugar, right? Similarly, we can have certain values. Let's say a value of 10, a value of 10.5, or someone has a marks of 82, someone has the name of Rahul. we can store all of these in something known as a variable. So which is what we'll do. Right? So we discussed that whenever we write x equal to 10, this does not mean that x is equal to 10. This is mean that the value 10. So we always start from the right hand side and go towards the left hand side when we're talking about variables. The value 10 is assigned to the variable whose name is x, right? So there is another thing in Python which is known as comments, right? So we always want to give some comments. We want to write some comments which are not executed, but are useful for the user to go through to read. Right? So in Python, we use comments by starting with the hash symbol or the hash symbol. So I can now say that the comment for this particular line is assign the value 10 to the variable whose name is x. Similarly, assign the value 10.5 to the variable whose name is y. Similarly, assign the value Rahul to the variable whose name is x. So we have 3 different types of variables. And in fact, it's also useful because we're starting out. 10 is an integer type, is an integer number, whereas 10.5 is a floating point float number, and Rahul is a string, right? So we have 3 different types of variables which we have assigned. And we can just get these in Replit just to show you. Let's say if this were indeed a program. So if you see the comment, the lines which had started with the hash symbol, they're all seemingly grayed out, right? So this is a help from the editor of Replit, which says that these will not get executed. These are there only to help the user and the reader to understand what is going on. As people who, when if you're starting out, I would highly recommend you start with comments. Even if you're experienced, it's useful to add comments. Sometimes it helps the evaluator or the examiner understand what you're doing. In large code bases, you want to put comments so that people who are also using the same source code have a sense of what you're writing. So we have these 3 variable names. Now, if I run python main.py, what do you expect to see in the console? So are we using any prints? No. So if I run python main.py, the program runs, completes, but nothing really happens, right? So let's also view another useful tutorial, another tool called pythontutor.com. So, and let's just put a smallish program over here. This was a program. This is the program we have written. This will help us visualize the execution. Right? So I press next. So firstly, it's important to understand that we execute line by line, right? So we had about 7-8 lines in the code. Most of these lines were comments. So this is a comment. These lines are a comment. The program straight away comes, the arrow points to the first line, which is going to be executed, which is line number 5, x equal to 10. Right? So think of it as it started with all these lines. 1, it said that it starts with a hash, not executing. 2nd, it's an empty line, not executing. 3rd, starts with hash. 4th starts with hash. 3rd and 4th lines are comments. 5th does not start with a hash. So 5th is a useful statement which the interpreter or the program which is executing this Python file has to execute. So it looks at x equal to 10. I click on next, which means that it runs through this line and goes to the next line. So then if you see that we have assigned a value 10 to a variable whose name is X, right? So this is what we discussed. Think of it as you're creating a small box. You have put the value 10 inside the box and you've called that box as X, right? Next line. So this is also useful. It shows green for the line which just executed and red the next line which is going to be executed. Again, why did line 6 not execute? It's an empty line. Why did line 7 and 8 not execute? They start with a hash, so these are comments. Line number 9 will execute. I press next. In this table where we're storing these values, so in this table which is actually stored in the memory of the system, we have the value 10.5 stored in a box and the name of that box is Y, right? Similarly, we execute the next line. The name of that box where the value Rahul is stored is in fact name, right? So we have 3 boxes, 3 variables, X, Y, and name, whose value are 10, 10.5, and Rahul. Right? Any questions thus far? Yes. So the question is, if we put all of these variables in a single line, how do you want me to write? X equal to 10, Y equal to 10.5 without any space, any break? So how do I put in a single line? Do you want me to write like this? This is not a valid syntax. And fortunately, the editor is also showing that it's an invalid syntax, right? So again, as you're starting out, so yeah, there can be ways you can use things like semicolons, but don't use that. So in the simplest form of Python, which we want to teach you without any edge cases, put each such assignment in a new line of code. That just makes the code more easily readable. That will prevent bugs. Does anyone know why we call bugs in computer program? What is a bug in a computer program? Error? Any other name for any other reason why do you think we call this a bug? Or any other explanation for what is a bug? Just one at a time. Yes. Yes. So previously, when computers used to be not like this box, right? Computers used to be, let's say, the size of this room, which could eat up the electricity for an entire city. The first failure of that computer program was due to an actual bug, actual insect, right? So from that time, when a computer does not operate as we want it to happen, it's called a bug, right? So in order to ensure that we don't experience bugs in our programs, so let's maybe put this way. So someone of you said that why don't we put all of these in a line? Now if we run the program, it says that invalid syntax, right? So there will be different kinds of errors, different kinds of bugs, problems that you'll see. Syntax error is one of those, right? So syntax means the rules of the languages are not being followed, right? So for example, we said that in the English language, there are certain rules. Each sentence has to end with a dot, right? Similarly, we have to have each line of code, each expression, as we say. In this case, we want it to be in a new line of code. Otherwise, the syntax is not being followed. Let's put this back here. And if we run the code again runs. Yes, other questions? Okay, so thus far we have been able to create certain variables and we've also been able to visualize these. So this visualization is very important. I highly encourage you to think about going through your program line by line and thinking how this memory gets created, right? We create a box, put the value 10, assign the name X, create a box, value 10.5, name Y, create a box, put the value Rahul, and the name of that box is name. So this seemingly simple thing will be helping you in avoiding a lot of bugs as you go ahead. Okay, so we have now created some variables, but by themselves, these variables are not useful because we're not either doing any processing on them, right? Or we are not giving any output using them. So next, let's just try and print out these variables. print X, print Y, print name. Now let's try and run this program. It prints the value of X, prints the value of 10.5, prints the value of Rahul, right? So the way this will happen is, so when it sees this line of code, line number 15, print X, right? Now it goes in this frame or in this memory. It sees that what is the object which is named X. What is the value of the object which is named X? The value of that object is 10. Grabs that value 10 and then calls it within print, right? So this would be saying that, so print X, right? We get a value of 10. This is going to be the same as print 10, right? Both of them will end up printing 10, but it's more convenient to use this variable because we can modify this variable. We can do various kinds of logical operations and other processing with the variable. But essentially, the way this line of code executes is that when you call print of X, it goes into the memory, checks that what is the value of the object whose name is X, right? Similarly, we can have printed all the other variables also. So in fact, if you want to see the execution here, and let's say we write print of X, print Y, so it again starts the execution. It creates this frame, and by this point of time, you have this memory 10, 10.5, and Rahul stored in X, Y, and name. And when you click on, when the next line of code executes print X, the value 10, which is the value of the variable X, gets printed to the console. Similarly, print Y, the next value 10.5 gets printed to the console, to the output. Okay, any questions thus far? Any questions? Okay. So there are certain rules which we can use to name certain variables, right? So how do we figure out those rules? So this is also related to the question many of you keep asking. What are the textbooks we should be following for this course? And what is the standard reply you've been hearing from me? No textbook, but if we don't use any textbook, what is the reference we still use? Sorry? You attend the lectures, but there has to be some other reference. So what reference should I be using? The Python documentation, plus we can also use, Stack Overflow you use when you want to solve bugs. I hope that for this course, you don't use Stack Overflow. You don't need to use Stack Overflow. You're able to learn, you're able to debug the problems on your own. But let's try and see some help, which, so if you see, we are on this shell. So previously we've been typing python main.py, name of the file.py, right? If we just write Python, we discussed this last time also, we drop into this interactive mode, right? In this interactive mode, you can do simple things like what you would, if you want to run small snippets of code, that's where you may want to use the interactive mode. You may want to write things like x equal to 10, right? So now, once you've written one line of code, that has already been executed, right? You don't need to write the whole program in order to execute this one line of code in the interactive mode. So you can directly now do print of x, and the value of x gets printed. You can also do z equal to 10.5, and then print. Right. And in the interactive mode, there is another very useful function or another utility, which is called help. So if I just typed help and says that type help parenthesis for interactive help or help of object for help about a certain object, right? So given that the screen is a little hard to read, I'll be running this help commands from my terminal window, which is just easier to read. But it's the same program, the same help utility, which we can invoke from Replit also. So I just type Python. I type help. Is the font readable at the back? Is the font size readable? You want me to make it slightly bigger? Right? So now if you open this, you see that welcome to Python 3.8's help utility. And this tells that one, you can go through this tutorial, which is the official tutorial. And then it says that you can enter the name of any module, keyword, or topic to get help on writing Python programs. So I said that there have to be certain rules in defining or using variables, right? Can you use, so previously there was a question on can we use 1 equal to 2? What would 1 equal to 2 mean? Can someone tell me? Assign the value 2 to a variable whose name is 1, right? But then the question is, can we have a variable whose name is 1? No. And so we'll come back to that. We can also try that out. But before that, let's try and see what are the other keywords which are defined in the language which you cannot use. So we go to help, we type, let's see. So they say that you can type some keywords. So I want to type some keywords. It tells me that there are these lists of Python keywords, which I don't want to be using as my variable name. Right? I don't want to be using false, none, true, and, as, assert, async, await, break, class, continue, def, del, elif, else. So these are the constructs. These are the reserved keywords which you should not be using. It's similar to the English language. Maybe you don't want to be using the name. Like say you want to name a kid, you want to name a person. You don't want to be naming that person the or a, the or a. Like, of course, some people may end up naming their kids like that, but you generally don't want to be using that. These are supposedly reserved words in the English language. Similarly, there are these reserved keywords in the Python language, which we should not be using. But it's always best to learn by doing. So let's come back to the interactive mode. Right, so let's invoke the interactive mode again. And let's confirm that we cannot use any of these as the name of a variable. So if I write from is equal to 1, it says that it's an invalid syntax, right? So the rules of the language do not allow for such syntax, right? Therefore, these are the words, these are the names of the variables which we should not be using, right? We can also do a bunch of other hit and trial methods. In fact, you can also invoke help here, perhaps. Yes, but could have also invoked help here. I was just trying to put the content here so that we know that what are the reserved keywords. I can just put some content here. So that when this class ends, this becomes your reference. Right, so these are some reserved keywords which you should not be using. But let's say we were again trying to use some keywords like this, false equal to 1. You cannot assign to false. We want to write for equal to name, some name. Does not work, invalid syntax. If equal to 10.5, invalid syntax. So I believe all of you are convinced at this point that we cannot be using such variable names, right? So therefore, let's maybe try some of the variable names also. So previously someone said that 1 equal to 2. Again, we want to read this as, we are trying to assign the value 2 to the variable whose name is 1. Cannot assign to a literal. Now let's see if so x equal to 2 clearly works, right? What about 1x equal to 2? Does this work? Again, this is not allowed in the syntax of the language. So you cannot have a variable whose name is 1x. But can you have a variable whose name is x1 equal to 2? This works, right? So sometimes you'll have questions of, can this work? Can this not work? Try it out. Right? It takes 5 seconds to just try it out. There can be some weird rules which no one remembers. So it's easier to just try out. What about x underscore 1 equal to 2? This also works. So print x1 works, print x underscore 1, this also works, right? What about x equal to 4 and small x equal to 3, right? So we can assign different values to variables. So capitalization or the case of the variable name is important. Capital X is not the same as small x, right? This is important for us to remember. So generally, when you're learning programming, it's important to consider the names of the variables which make some sense, right? So maybe let's try and write a small program to add two numbers, right? Let's go back to a replet. So we want to be adding two numbers. Right. So this is a valid program. So I had a variable name whose name was ABC. I assigned the value 1. I had another variable name whose name was OPSER, some random name that I had given. This is a valid name allowed by the language, but is it a very good name? No. So some other names which might have been other useful. Let's say first underscore number equal to 1. Second underscore number equal to 10. Print first number plus number. Is this a better program already? Right now the names of the variables are making much more sense. This is indicating that this is the first number, second number, right? Sometimes we end up using very cryptic names, but most of the times the code is being read and not written. So this means that in large code bases, you want to be reading your old code, but it's often the case that people sometimes they're very smart when they're writing programs, but you need to be smarter when you're debugging programs or when you're checking the programs. So therefore, important to have certain good variable names. Okay. So we've seen various kinds of useful and working and not working variable names. Okay. So thus far, we have already seen certain types of the inputs, right? But we can also always go back to this help, right? So by the way, if we want to exit this help, I just press enter. I can exit this help utility. I type help again. I want to see what are the different kinds of types of data that I can have. So in the spreadsheet application, we said that we can create various types of numbers. We said that we can create various strings for the names. We can have some floats for the marks of the person. But if you type types in help, this is going to give us various kinds of types. So again, there might be people who have already studied programming, but you may not have seen all these types. There are a lot of types which exist, and there is some natural hierarchy which exists. So it would be useful for you to also pay attention now. So it says that below is a list of types that are built into Python, and they do mention some type hierarchy, right? So if we just go through this, anyone here heard about the type ellipsis? Those who studied programming earlier, heard of the type ellipsis? Okay, so if not, you should just look into this for the people who have already done programming. So then you have numbers. We have various kinds of numbers. We have integer numbers, right, which we've already seen. We were using the integer type for what attribute in the spreadsheet? Why were we using the integer what were we using the integer to represent in our spreadsheet application? No. Tell me the exact answer to what? The roll number, right? We said that the roll numbers were integers. There is another data type called Booleans, right? Have you studied Boolean algebra in class 11, 12, right? So we're dealing with true or false. So this specific data type can take only two values, true or false. The way we write true and false, so we have different types. We have integers, We can have negative integers also. And we can have booleans. So way we write these booleans is the keyword true and false, right? So true means true or 1 in the Boolean zebra circuit, and false means 0 or false, right? So Boolean is another data type which exists. We have floats. We can write x equal to 10.5, y is equal to minus 10 point something. We have complex. So anyone use complex number? Have you used complex numbers in mathematics? Where do you use in mathematics? Tell me any complex number. Iota. So you can represent complex numbers with, so each complex number has how many parts? 2 parts, a real part and an imaginary part. That is what this data type also contains. You can have a real part and an imaginary part. You can have sequences. So previously we said that we can have a single row, and a spreadsheet is a sequence or a list of rows, right? So in sequences we have things like immutable sequences, which includes things like strings. So we've already been using strings. Let's say second is equal to, right? We can have these strings, which importantly are enclosed in these quotation marks, double quotation marks, right? And we want to represent a character of strings, a character of the English alphabet through these. We can have other data types such as tuples. I'm not writing them here, bytes. And then we can have mutable sequences, which means they can be modified, which includes things like lists and byte arrays. We can have mappings to include things like dictionaries. And then we can have things like functions, etc., right? So we have now seen that we don't actually need to go into any external documentation. You don't need internet. All you need is a device where you have Python installed. You can invoke the help utility there, and you can read up a lot about the different types that you can have. Okay, so now we have already seen the different types of these variables. We can also use a very important useful function in Python called the type function. So what do you think intuitively by just looking at the name or just hearing the name type? What do you think a type function might give you? So first, it's a function. In mathematics, we've been dealing with functions which accept something as an input and give something as an output, right? So this is just a very simple introduction to functions. We'll do a proper discussion later. So let's say we have some functions. We write f of x equal to sine of x, right? What is the input to this function? What is the input to this function? X. What is the name? What is the name we are using for this function? F, right? And what is the output from this function? Sinusoidal of x, right? That is what is getting returned. Similarly, we have a function called type of x, right? The input to this is some x. The name of this function is called type. It will return something. What do you think this will return? The data type of the input argument, which is x, right? So if we give type of 10, what do you expect? So 10, which is an input to this function. So if you're getting confused, you should just look at, so here we have f is the name of the function, and x is the input, and the output is the sine of x, right? Similarly, type is the name of the function, what is the input to this function? 10. Output is the data type of 10, right? And if we just execute this line, we get that the data type of 10 is an integer. Right? We can just copy paste this and run it here also. We run python main.py. I don't see an output. Why? I have not printed anything, which might have been, sorry, confusing to some of you. Let me just write it this way. Right. So the type of 10 is an integer. So if I write the same thing over here, I want to print the type of 10. It's printed as a class int. You don't need to worry about what is a class. Just think of it as it's a data structure, and it's telling us that the type of the input being passed to the function type is an integer. Right? So what do you expect the output of this function to be now? If I run this, what should be the overall output you will see? First an int, then a float. Because we're printing both. 10.5 is of type float, 10 is of type int. This is a string. We run the program of type string. So we get printed int float string. Right? But importantly, we could have done the same thing. Right? So if I just wrote a variable x equal to 10, I can print the type of x, type of y. So I'm now assigning these values to these specific variables. Right? What do you expect the output of this program to be? The same as before. X equal to 10 means assign the value 10 to a variable whose name is x, print type of x. Right? So this will, let's go over this one step at a time. So first we have this type of x. First it picks up x, puts its value inside this. So this then converts to, okay, so let me just write it out for you. So we had this line of code. Right? So what this would do is first get the value of x, right? So then this above line will get translated to type of the value of x is 10, right? This gets put here. Next, find type of 10. So therefore you get print of type of 10 as integer. So this would be class, int, whatever, right? Whichever way it decides to print. And then finally print class int to the output console. Right? This is how you're breaking this function or this one line of code into how it will get executed. First, the value of x is substituted to 10. Then this type of 10 gets executed, which returns integer, and then you print int. Okay, any questions thus far? True, false, Boolean type, we can also type. Print type of false. It prints that the type is Boolean. I could have also printed type of true. That could have also been a Boolean. Yes, any questions? Class, what do you mean by? One at a time. Okay. What is using? Oh, so if you run this line, yeah, this will give you an error. So what I was mentioning was that the type of 10 would be class int, something like that. That's a type object. You don't need to worry about that. You don't need to be executing this kind of code. I'm just showing that internally how Python will keep on executing these things. Yes, other questions? Why did I write this line? I was just trying to show that if you type print type of X, it's not that magically you'll get class int as the output. You'll have to have you seen function composition? Have you seen a function fx and a function gx? Have you seen fo-gx function composition? This is what is happening. You have an inner function type of x, which will first get evaluated. Type of x, the first thing which will happen is the value of x will get substituted to 10. Second, the inner function will get executed, which is, so this is actually not very different from, if I write sine of cosine of x, evaluate sine of cosine of x at x equal to whatever, pi by 2. What is the value of this expression? What is sine of cosine of x at x equal to pi by 2? Right. So first you'll put the value of x here. Right. So this gets converted to, this will get converted to sine of cosine of pi by 2. What is cosine of pi by 2? This is basically sine of 0, and which is 0. Right. So I was showing how the program would execute this, right? So nothing happens magically. It will happen step by step. Substitute the value of the input x equal to pi by 2. Then this function will return sine of cosine of pi by 2. But cosine of pi by 2 is 0. So therefore sine of 0, which is 0. We have done the same thing here. Print type of 10, print type of x, substitute the value of x as 10. Type of 10 is integer. And then you're printing integer. This is what you get. Other questions? Just one second. Okay. So whenever you have such questions, these are very good questions. You should just try them out. And I'm not going to the details of this because Python has changed the convention. Earlier, they used to be long like things, but without going into the detail and confusing people. So the question is, if you were to type of 10, you get an integer. There's no problem in that. If you increase the number of zeros, it's an integer. Increase the number of zeros, it's an integer. It's an integer. Yes. So in Python now you can store arbitrarily long integers. So maybe let's go to the help and actually check this if we can find something. Okay. So if you just read through this line, there is no limit for the length of integer literals apart from what can be stored in the available memory. Right? That's why it's important to go through the documentation. You can refer to some online articles which may not be updated, which may have incomplete information. But if you refer to the documentation, that is maintained by the people who have created the language, who are maintaining the language, right? There are various other kinds of things also which you'll see, right? Again, most of the textbooks will not cover these. But if you're curious, you go through the documentation, you'll see that maybe there's something like a hex integer. What does that do? There's something like a digit. What does that do? Right? So there's a lot of things that they're mentioning in what you can do with an integer. Yes, that was a good question. Other questions? Just one second. Let me just write. There is no limit to the size of an integer. And if you want to give the reference, want to refer to help integer. Yes, there was a question. Yes, go ahead. How does the output? So Jupyter Notebook is, they have created certain hooks. They have created additional things. Let's again not go into the details of that. For now, you should just be using prints. So Jupyter Notebook, you should not be using if you've not done programming earlier. You should be sticking mainly to Replit. And so think of Jupyter Notebook as an extended or a enhanced version of the terminal, of the interactive mode, right? So maybe if we just go to the terminal, right? We have Python here. So had x equal to 10, right? I am not using print now. I write x, the value is 10, right? So the interactive mode in Python, without using specifically print, it just prints out those values of the variables, right? Jupyter Notebook is an enhanced version of this. You can think of that way. Yes, other questions? The data type complex. So I'm not going to tell you that. You'll have to read through the documentation to see. But I can show you the documentation for that. So go to complex. Right. So imaginary literals are described by the following lexical definitions: float number, then the digit part, J, small j or capital J. So they mention that you can give, so 3 plus 4j, right? Maybe since you've asked for it, let's try that out. So if I write complex equal to something, is that a valid statement? Should I be doing that? Complex is a reserved keyword. I should not be writing that. Complex num is equal to 3 plus 0.5j. Complex num is 3 plus 0.5. The real part is 3. The imaginary part is 0.5. The real part is 3. The imaginary part is 0.5. Right. So you can be using these data types, advanced data types also, although for most of the things you'll do in the course, you don't require a complex data type. But it's useful to think, can you create such data types? Let's say the complex data type did not exist in Python, in the standard library. Can you create that? Perhaps you can. It's not very difficult if you know other data structures which you study. Things like tuples, things like classes, if you learn those, you should be able to create complex or new data types on your own. The double data type. So, okay, let's just search for that. So this question is coming from someone, so where was the question coming from? Okay, so are you coming from a Java background? Okay. Let's see. No. So if you just search for float, right? So you get that floating numbers literally are described by the following lexical definitions. And you can look at the precision and the other details which we're discussing about float here. But again, I don't want to discuss this in detail because there are people who have not studied this earlier. We'll be having a single data type for representing decimal numbers called the float. Yes. Other questions? Okay, so we have already seen certain kinds of types of objects, right? But we can see that if we want to transform the type of an object into some other type of a variable into something else. So why do you think that will be useful? Why do we want to be able to transform the type of a variable from one thing to another, from one type to another? Okay, so I think everyone perhaps needs a break. So why don't we all take a 5-minute break? Don't go outside, or if you want to go outside, just come back in 2 minutes. Just take a quick stretch break, and then we'll resume the discussion. So we'll start sharply in 5 minutes. If you don't come, that's your loss. Okay, let's settle down. Okay, let's settle down now and continue the discussion. Yes, everyone, you've had your 5 minutes, more than 5 minutes. Okay, so the next thing we're going to be discussing is type conversions. So let's say we had a variable x whose value was 100, but in a string, right? So the value of x is a string type object, which is whose value is 100 within the string. If we were to write print type of x, what do you expect? String? The string. You can also just and if you were to run main.py, you'll get it's a string type. But let's say we want to get the integer out of this. So one, you can remove the quotes, yes. But let's just assume that we had made a mistake or we cannot remove the quotes. Just 1 second. Yes. Exit. So I wrote exit because earlier I was in the interactive mode. I want to exit it. I want to exit that, and I wanted to come into my shell. So if you saw, I was in this interactive mode where I see these triple arrows. Right? That is the Python interactive mode. I typed exit. I exited out of that. I came to my shell where I can write Python filename.py. Right? So we wanted to convert the x, which is of type string, into an integer. So again, int is a function. So let's just go back here and see what did we write with the function. We wrote that fx is a function which returns sign of x. The name of this function is f. The input of this function is x. The return value of this function is sign of x. Similarly, we have a function, right? So what this means is we have a function with name of the function as int, argument or input to the function is, what is the input of the function? The value 100. Right? And output from function is, what is the output from this function? It tries to convert the input to an integer. So I've importantly written the word tries. Why do you think the word tries is important here? So this is where things get a little interesting. X is a string, and in the string we have the characters 100. Y is the int of x. So y will try to create an integer out of this 100 string. I'm printing x, printing y. What do you expect to see in the output? What do you see? I have printed x, right? So x is a string type, right? But it gets printed as 100. Y is a string type, sorry, is an integer type, gets printed as 100. So what do we do about this? So one, you have to be careful that when you're printing, that what is the type of the object that you're printing, right? Eventually everything gets printed or seen in the console like a string, right? but it's important to understand that what are the types of these variables. Therefore, you may also want to write print type of X. And maybe I can also print some various things as separators. I want to just have I printed Y, and let me print the type of Y. And if I execute this, I see that the type of X is a string, whereas the type, what are you not getting? You'll have to be a little louder. Yeah, because I've not explained that yet. Just give me a second. I'm just using that to separate out these two information that I'm printing out. So I'm printing, let me just go over this line by line. X equal to string 100, double quotes 100 means that assign the value, double quote 100 or a string type 100 to the variable X. Y equal to int of X means first put the value of string 100 in this function integer. It tries to see that what is the integer object value stored here, which is the integer 100. So Y at this point of time is assigned the integer value 100. Let me actually just show the difference in the Python tutor. I think it will become clearer. Right? Do you see the difference between X and Y? So X is the string 100, Y is the integer value 100. I print X, print the type of X. We've already done this. X is printed as 100. The type of X is integer. Then I have this weird looking statement. There is some symbol that I'm printing. So what is the type of this thing? Anything which is enclosed in double quotes is a string. And I've written into 20. And do you think I'm seeing 20 such hyphens? Right? So that is what this line is doing. It's taken a string. We're not going to the detail of strings yet, but this was just to show that we started with a small string. I could have written, let's say, some other string, right? Now does the pattern make sense? So into 20, when we write on a string, that just repeats a string that number of times. So this will just repeat hyphen star 20 number of times. We often use such things just to make our printing easier, or output easier to look into. Yes, and then I printed Y, the type of Y. As expected, the type of Y is an integer. Any questions thus far? But importantly, we also need to see that where such conversions may fail. Right, so if we were to write int of ABC, what do you expect to get? Right, so you're trying to pass into this function ABC, and into the function int, you're trying to pass in ABC, but you cannot convert ABC into an integer. So you should end up getting something like an error. You get a value error, which says that invalid literal for int with base 10 ABC. So let's just copy paste this here and just try and run this to show you the error here itself, here also. The error is invalid literal for int with base 10 ABC. So it's not able to convert the ABC string into an integer object, right? So, yes. So let's get into that. Okay. Just give me 1 second. So we wrote ABC as a string, try to convert into an integer, does not work, right? So we get an error. Now there are methods to handle this, which is known as exception handling. Let's not get into that again at this point of time. At the correct time, we'll get into that. But we've seen that we need to be careful while trying to use the int function also. We can't just pass anything and get some integer output of that. Similar to this, we have a float function. So we wrote 10.56 and the float around that. What do you expect to get? So let's say that z equal to float of 10.56, print type of z. So z is now a floating point number whose type is like it's a float type, right? Whereas this thing 10.56 enclosed in the double quotation marks was a string, right? So we had this function int, we had a function float. We can always go back to documentation. So let me show that again. I think it was that quick. It was very quick. I went to help. I wrote int. Int is the function which I'm trying to get more information on. It converts a number or string to an integer or returns 0 if no arguments are given. So this is interesting. So I didn't know about this. That's why it's always good to read the documentation, right? So it returns 0 if no arguments are given, which means that if I were to run something like y equal to int, right? And print y, what should be the value of y? 0. Y 0. This is as per the documentation, right? So that's why reading the documentation always makes you learn new things. If x is a number, it returns the integer of it. For floating point numbers, this truncates towards 0, right? So what do you think this thing means? What do you think truncates towards 0 means? Let's just try this out. So it says that for floating point number, it truncates to 0. I have this function int. Within string, I write 10.61. Invalid literal for int with base 10, right? But what have we done wrong? The documentation said that for floating point, we'll get. So if you can just hold on for a second, let me ask the entire class. So I read the documentation, which clearly mentioned that for floating point numbers, this truncates towards zeros, which means that if the input is a floating point number, this should just truncate it to have no decimal numbers, no decimal points. But I just gave the same thing here. Int of 10.61 gives me an error. Why is that? For floating point numbers, for floating point inputs, this returns after truncating. So int of 10.6, it's removed the decimal, right? But int of 10.61 is not going to work, right? But if you indeed wanted to get it to work, you could have written int of float of 10.61, you get a 10, right? Again, this is function composition. First float of 10.61 gives you the floating point number 10.61, and then you take the integer of that, you get 10, right? I can't hear you. Which line? Which line? So 44, 46, which one do you want me to read? If I remove the float, if I just write int of 10.61, yes. The output should be an error because this string is not an integer. When you try to convert this string into an integer, you get an error. If you have, you'll have to be a little louder, please. No, so that's how the language works. So that could have been a design. So the question is that why does this not return 10, integer 10, right? But that's by design. So it's chosen in the Python language that integer of something which is not an integer will give you an error. If you want to get the correct answer, the way you have mentioned, you'll have to convert that to a float, which becomes a floating point value of 10.61. And then you can get an integer out of that, this 10. Okay, questions? Why does it make sense to convert floating point numbers to integers? Why do you think that makes sense? Why would you want to do that? N? Sorry? The greatest integer which is lesser than equal to the value. Okay. There is a flow function also, yes. But the integer function just truncates the decimals, right? It just removes the decimal points. Okay. There is a round function. Yes, there's another function called round function also, which can be used to round. And where do you think we'll use things like rounding and finding the closest integers? When we're trying to grade, right? Let's say your marks end up being 94.345, right? I may want to round it off to the nearest integer before I do the final grading. Okay. So we have seen conversions of strings to integers and floats. Can we do the reverse? Can we do, let's say we had some number variable a equal to 10, right? If I do b equal to str of a, what do you think b will be? Again, just printing is not going to be sufficient. So a is the numeric type 10. I convert that into a string using this function str. We can again just go back to our documentation. Look at the function str. Creates a new string object from the given object. Right? It's much more complicated, but we are just using it for a simple function. A is 10, b is string of a, and the type of b is string. So where do you think this might be useful? To convert integers to strings. For large calculations, you want to do what? Okay, and then? So the answer that you're giving is perhaps a competitive coding answer useful for the situations when you don't have infinite large integer arrays. Sorry? For roll numbers, you can convert them to strings, but why do you want to do that? You don't want any integer operations? Okay. You can use them in a password. Okay, so all of these are valid answers, but let me just show you a fun experiment, a fun question. So let's say I ask you to find the number of digits in an input integer, right? So I have an input integer, x equal to, how many digits do you think this has? No, 25. How do you know that? Do you see that? Okay. We'll check that. We'll see. But how do you see that? How do you say that? Okay. Sorry? Okay, so the question is, it's a mathematical question, right? I want you to find the number of digits in this long integer. How would you do that? How many digits do we have in the number 100? 3. How do you know that? You count 100, but mathematically, if you have to tell an algorithm to figure out. Okay, one at a time. Anyone can figure this out using a simple mathematical form? Yes. Forget about converting to string. That's an efficient way. Like, I'll show that. Leave that up to me. Modulus. What is modulus? But why do we want to know the remainder? Okay. So, okay, that's fine. That's a appropriate answer. How many of you remember using things like the abacus? Right? Must have been a long time back. Do you remember things like writing the ones, tens, hundreds, thousands? Right? So is that an exercise we can do here? You can, or another thing you can do is you keep dividing the number by 10. Right? You start with this number. You start with 123, like. Right? If you were to divide by 10 and forget about the remainder, right? So if we divide by 10, then what do you get? 123 you divide by 10, you get 12, remainder 3. 12 you divided by 10, you get 1, remainder 2, right? How many times? And 1 divided by 10, you get 1, right? So, or we can just stop there, right? So we had 2 divisions here. So the number of digits in this will turn out to be 2 plus 1, which is 3, right? So that's one way to do. You keep dividing the number by 10, forget about the remainder, and the number of divisions that you get, you add a 1 to it to figure out the number of digits that you have there. But there's a simpler way around this. Okay, how many digits? Too slow. You're too slow. So X is this large number. I convert that to string. Print Y. It just printed out the value. Now strings have an interesting function which you can operate on them, which is called the length function. We can figure out a length of a string. So let's say if we had a string E equal to some hello, and if I print len of E, so it tells me the number of characters in that string. 1, 2, 3, 4, 5. Right? It has 5 characters. It prints that it has 5 characters. I could have done the same thing. So print len of Y. Y, if you see, is a string representation of X. X was a large integer. Convert that to a string and find out the length of that. 38. So let's just check the previous one. Oh, I deleted the previous. Let's see if I can still get the previous one. To check if it's at 25 or not. Someone from the audience said this 25. Okay. $29. Okay. So that's how we can use the string function, the int function, the float function to convert the data types into various other data types. Any question till now? Yes. Okay, good question. Why can we use the length function in integer? Length of 10. Object of type int has no length. You can't use. Length function will work on sequence-like objects. String is one sequence-like object. String is a sequence of characters. Integers we don't necessarily see as a sequence of characters. Right? So the length function will not run. But these are all good questions. I want you to be thinking about such questions. Why do we need to convert explicitly from an integer to a string? Why do we waste that additional processing? Right? Try those things out and you'll figure out from the errors itself that this does not work out. Okay. So the question is that we had some floating value, some val 10.56. We convert that value into a string, store into, let's say the variable name is str of val. Print str of val just to confirm that this is. Okay. So this will just print out len of str of val. What should be the output? Now it sees 1 as a character, 0 as a character, dot as a character, 5 as a character, 6 as a character. How many characters? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. Just 1 second. Sorry. E dot len. So the question is, we had str value dot len. No. So then there is some other cool thing that you can use. You can, so that will involve you to read a little bit more documentation, and that has to do with using something like these double underscores. But again, this is not something I want everyone to look at this point of time, but if you're curious, you should look into it. For now, use length. What is length? What is len? No, what? It's a function, right? So whenever we see something like this, you have a certain name and you have this opening parenthesis, closing parenthesis, and an argument in there. You should just be reminded of what you studied in mathematics. This is some function f of x, similar to f of x. This is the argument or the input to the function. This is the name of the function, and this is just a convention of f of x, right? That's how we pronounce it, f of x. So this is pronounced as length of string value. Right? So length is a function. Use the functions in this particular way. It's other questions? The way he mentioned. So internally, you may end up calling the internal representation, which I was saying. Right? That is how it will eventually get calculated. But at this point of time, we're using this as a function, right? A function, general function we're using. And in that case, we're using it as a function of a specific type of an object, of a string type. So that's attached. So that will become clear when you study things like classes. So then that particular function is belonging to that particular class, right? But again, sometimes more curiosity means more confusion. So let's not dive into this. Other questions? Okay, so we have seen thus far some interesting things, but now if you want to be doing some more useful things, we need to be doing some calculations, right? So what are the things that your calculator allows? Addition, multiplication, what else? Percentages, divisions, square root. It also allows you to do things like compound interest, right? Accumulation, right? So now what we'll be doing is, thus far we have seen that we can say something like x equal to 10 and y equal to 5, right? But these are simple assignments. We want to be going from something simple like an assignment to doing something useful, which is an actual calculation, right? So we can have a simple calculation, z equal to x plus y, right? Now, what does this mean? Does this mean that z is equal to x plus y? No. Z is assigned the value x plus y, right? If we run this statement, again, what happens? The value 10 gets substituted for x. The value 5 gets substituted for y. So z is equal to 10 plus 5, or z equal to 15, or z is assigned the value 15, right? So I want all of you to go through this. If you've never done programming earlier, just go slow. Z equal to x plus y, put the value of x, which is 10, put the value of y, which is 5, z equal to 10 plus 5, z equal to 15, which means z is assigned the value 15, right? Or if you want to go to the Python tutor, so it creates a variable x, value 10, creates a variable y, value 5, creates a variable z, value 15, right? So this is one such simple operation that we have done. But let's say we're new to the language. So we clearly know that there will be some things like, if we can add numbers, we can also subtract numbers, right? That seems obvious. What do you expect the value of z to be now? Right, z is 5. How do we multiply two numbers? Star. But how does star come into being, especially for people who have never done programming? What is the symbol for multiplication we generally see in mathematics? It's a cross, right? But Python maybe doesn't have that. So it has something as an asterisk, but let's see the help to see if we can, the help can help us out. Okay. So plus, minus, divide by, and modulus, all of these things are known as operators. Right? Have you heard of this term before, operators? What is the difference between an operator and an operand? So we have mathematical operations, and they involve things like operators. We have various operators in this. I'm going to be showing just a small subset of them. Plus, minus, addition, subtraction. So this star symbol that you're seeing, which is on your numeric 8, right? So it's on number 8 in your keyboard. That means multiplication, right? So if you want to multiply two variables in Python, we need to use the star symbol. And then there are various other symbols. So there is a divide by symbol, which is a forward slash. There is a double forward slash. So forward slash means divide. Single forward slash means divide. Double forward slash means floor division. Percentage means remainder. Star star means exponentiation, which also means raised to the power. And there are various other such expressions. So operators that you can use. Right? Again, you didn't need to look at any internet resources. All you need to do is to go to help, type operators, and then just read through this. Right? So using this, we can now write some useful programs. X equal to 10, Y equal to 5, Z equal to X plus 5, X plus Y, print Z. Okay, the output is 15. That is fairly clear. Now, what do you expect the output to be? What does star star mean? Raised to the power, exponentiation. So this means Z equal to 2 raised to the power 5. So mathematically, this is X to the power Y. Right? That's a symbol you may have studied in mathematics, or X raised to the power Y. Right? 32. 2 raised to the power 5 is 32. 2, 4, 8, 16, 32. We can also try out the other operators. So if we do X divide by Y, what do you think the output would be? So what is 2 divided by 5? 0.4. Let's see the output that we get, whether Python respects a mathematical conventions. Okay, so you indeed get 0.4. Actually, it's better if I just run it here. So you get 0.4, right? But we also saw that there is something known as a floor division. So floor division, let's just try and run this. We get the value 0, right? So 0.4. So we were to divide Z, or we were to divide X, we were to do X divided by Y. That returns a number which is lesser than 1, right? So if you take the floor value of that, or the nearest integer lesser than that value, which is a 0. So that is what floor division does. Or mathematically, you can write that, you can write 2 divided by 5 as 5 into 0 plus remainder 2. Right? So I can actually show this. This also becomes useful when we study this concept of modulus operator. Okay, for some reason I'm not able to share, but think of this as you're doing X divided by Y. So we can always write 2 is equal to 5 into 0 plus 2, right? Can we write 2 is equal to 5 into 0 plus 2? So this 0 is what gets returned in the floor division. This is the 5 you're dividing by. This is the 2 that you get as the remainder, right? If you were to do, if this number that you want to use is limited to be an integer, right? Then you can only write 2 is equal to 5 into 0 plus 2, which means that the value which is returned, Z equal to X floor division Y, is this, right? So this is the value of Z which is returned. So we could have also done, let's say, another variable, X percentage Y. If we go and look into the operators, so percentage means remainder. So if I divide 2 by 5 and I'm only allowing integer numbers, we'll get the remainder as 2, right? So if we write 2 is equal to 5 into 0 plus 2, the remainder is 2, and Z gets assigned the value 0. So if we print Z and we print the value 2. The value 2 is the remainder that we're getting. We could have also just maybe put right. Does everyone understand this? The modulus operation tends to be a very useful function, very useful operator. So we have seen various such operators here. So let's take up a very typical question. How can we tell whether a number is even or odd? So if we look at the first few numbers, let's just try that out just to make it easier for people who've never seen programming. If I do 1 modulus 2, what do I expect to get as the answer? So 1 modulus 2, for this, we can basically do 1 is equal to 2 into 0 plus 1, right? So this is the remainder. This has to be an integer, right? So 1 is equal to 2 into 0 plus 1. The remainder is 1. So therefore, if we do 1 mod 2, we'll get, what is the answer? 1, right? But if we were to do 2 modulus 2, so we can just rewrite this. 2 is equal to 2 into 1 plus the remainder is 0, right? So if we do 2 modulus 2, what is the answer? 0. Just copy paste these things. 3 modulus 2. So 3 we can write as 2 into 1 plus 1 is the remainder. So therefore the remainder that we get is 1, right? So can you see that with odd numbers, odd integers, the remainder is 1. With even integers, the remainder is 0 when you divide by 2, right? So percentage is the modulus symbol. Sorry, percent is the modulus symbol and gives you the remainder when you divide x by y, right? So if this is confusing, I would always encourage you to write it in this way. It takes you only half a second more or 1 second more, but this will give you a lot of clarity that you write the number you're trying to divide. This is basically if you had, or in general, if you had print x modulus y. So you're basically trying to write x equal to a into b plus the remainder, right? This is what, sorry, a into y into b plus remainder, right? So if you were to do x modulus y, you will be returned the remainder. If you were to do x floor division y, you will be returned b. If you were doing x divided by y, you will be returned the decimal number, which represents the division. Questions on this? So a lot of these things may appear very simple when you first hear them in the lecture, but if you don't practice, you may not be able to get the grasp of them. Right? So this is a very simple program that we have thus far seen, that we can check whether a number is an integer or whether it's a number is an even number or an odd number, right? So we have seen some simple operations now, but we can build some more complicated expressions also. So let's call them some complicated expressions. So let's say we were to write x equal to, I have an example, 1 plus 2 okay. What is the answer to this question? What is x equal to, what is the value of x you want to store? X equal to 1 plus 2 into 3 divided by 4 into 5. So why don't you all of you just solve and then let me ask some of you. Someone says 11, someone says a 1.4. Okay, let's see other answers. So all of you should just try to work this out in your copies. How many get the answer 1.4? Quite a handful of you. How many get the answer 11? How many get the answer which is something different? What is the answer? 1 plus 2 to the power 15 by 4. So 1 plus 2 to the power around 4. So 2 to the power around 1 plus 16, something like that. So you get an answer 17. Okay, other answers? 11. 8.5. Okay. So all of you are getting different answers. Why is that? Some of you have applied BODMAS, but does Python apply? Does Python use BODMAS? Okay. So let's again take the help of our documentation. So when I wrote operator, it gives me the following documentation. The following table summarizes the operator precedence in Python. So operator precedence in Python means that the order in which you should be doing the evaluations. From lowest precedence to the highest precedence, operator in the same box have the same precedence. Unless the syntax is explicitly given, operators are binary. So then let's start. Let's look through the operators that we're using in our code. We have plus, star star, divide by, and multiply. Right? So we have plus, star star, divide by, and multiply. Let's just see that where do they occur in this operator sequence. Okay, which is the first one that you see? The first ones that you're seeing are plus and minus, right? And if you saw the table, if you saw the documentation, it says that we are going from the lowest precedence to the highest precedence. So when we're doing the evaluation, plus and minus will get the lowest precedence. They'll be evaluated last at later stages. Then multiply and divided by will be multiplied earlier than them. But the thing which will get multiplied, which will be evaluated first is the power or the exponential or the raised to the power. Star, right? So essentially this will boil down to x is equal to 1 plus 2 into 3, 2 power 3, right? So this is the meaning of operator precedence, that when we had to calculate this expression, we looked at the table and we'll be able to remember this after some point of time, that the highest precedence amongst the operators which we have, that's operators we have are plus, power, divided by, and multiply. In decreasing precedence, we have, okay, the first one would be multiply, raised to power, and then we have divide and multiply at the same level, and then we have plus, right? So we had x equal to 1 plus 2 into 3 raised to power 3 divided by 4 into 5. We've seen that firstly, the most important, the thing which has the higher precedence is the raised to the power. So then this evaluates to x equal to 1 plus 2 raised to power 3 divided by 4 into 5. We can calculate this thing now. This will get calculated as x equal to 1 plus 8 divided by 4 into 5, right? And this is where the confusion comes in. Now you have divided by and star. So the question is, should we do, we have option 1, which is x is equal to 1 plus 8 divided by 4 into 5. And we have option 2, which is x equal to 1 plus 8 divided by 4 into 5. Which of the two do you choose? Why? And why do we choose left to right? We choose option 1. Again, we look at what the documentation says. Operators in the same box group left to right, right? So when you have the operators in the same box, like you had plus and minus, or you had star multiplied and divided by, you go from left to right. You do the calculations from left to right. Therefore, left to right precedence. So therefore, we'll end up writing x equal to x equal to 1 plus 8 divided by 4 into 5, right? Which gives us x equal to 1 plus 2 into 5, right? We again have two options, 1 plus 2 into 5 or 1 plus 2 into 5. Which do we choose? We choose 1 plus, so and this we can then write as 1 plus 2 into 5. Why do we write it this way? Because we're now comparing the precedence of plus and multiply is higher. So therefore, we end up writing this as 1 plus 2 into 5, which will evaluate as 1 plus 10, which will evaluate as x equal to 11. Right? So we have done a bit of jugglery. We have calculated this answer. I can actually just show if you were to write the entire expression. If you were to write this expression and do a print of x, we get 11 as the answer, which is indeed correct. We end up getting 11.0. Why is that? So when we end up using things like divide, so when we enter into something which leads to decimal places, we end up with 11.0 instead of 11. So this is a common source of error in your programs. Should we be writing programs like this? So this is perhaps a good question for a quiz, for an assessment. But should you be writing a program in such complicated expressions? No. So you should always try to make the job easier for someone who's reading your code and for yourself also. So the ideal way to write this would have been x equal to 1 plus 2 raised to power 3 divided by 4 into 5. Right? This is a far better way to write the same thing. It's just that it's a little more verbose, but I would always prefer verbosity over complication, over confusion, right? So I would say never write expressions like this, even though you may know the precedence order, but sometime you may just get it wrong, right? This just makes it very clear that what you're trying to do. What is that you're trying to do? Okay, so we can stop at this point, take additional questions. So people have been missing attendance in the past as you directly just rush off. So please fill your attendance before you leave. The other announcements is that we're starting the labs from today onwards. The questions are already made public, but in the lab sessions, they'll be clarified further. We did discuss about having an assignment, worksheet on Wednesday or Tuesday. When did we say that? Wednesday, right? So we'll have it on Wednesday. So some of you are asking what are the kinds of questions to expect. This is one kind of the questions to expect. If I give you this expression, what is the value of x, right? Or I can give you some other expressions on other questions on print the value of, and maybe I give you questions like type of something. You have to tell whether it's a class or whether it's an int or a float or something. So the kinds of things that we're doing in the classes is the kinds of things which will be asked in the worksheets, right? I also said about having an extra class tomorrow. Most probably that is on 4 p.m. the same venue. But if we have a change of plan, I will let you know. There's a lab from 2 to 4. It's not from 4 to 6. You have a lab 2 to 4, right? Not 4 to 6. 2 to 4. So you'll be free at 4. Sorry? Yes. Any questions? You have to be louder, please. Yeah, matrix multiplication here, but I'm not going to show you that in this class. I can show that outside. Yes. The flow division mathematical operation. Okay. So if anyone is not yet added to Replit, I still see about 280 odd students only, while the strength of this lecture of this class is 320, 330. If you're not yet added to Replit, please go to Slack. There are other people also beyond what you know. So there are about 320 odd people. So there are other people also. Please go to Slack, figure out the link for the Replit, and please sign up there. Otherwise, the labs, you'll end up wasting time on that. Other questions? Yes. Decreasing. Okay. So there are a couple of questions on decreasing precedence, and then there is a question on flow division. So let's just go over them again very quickly. So x equal to 11 by 2. What do you expect the value of x to be? 5.5. X equal to 11, flow division 2. So this effectively means that I'm trying to write x equal to 2 into 5 plus 1. Right? What is the remainder when I divide 11 by 5? By 2. Remainder 1. And the answer that I get by flow division is 5. So then I'll get print x as 5. Right? There was a question on operator precedence. So for operator precedence, we go from the bottom of the table as the highest precedence, and as we move up the table, the precedence decreases, right? So in the common set of operators that we use, so forget about some of the non-trivial ones. The common set of operators that we use, the highest precedence is for the brackets, right? You have explicitly for brackets. Those will get evaluated the first. Then what is evaluated is the power. Then what is evaluated is some other operations, but then multiply, divide, flow divide, modulus, all of them are the same level, are the same priority level, and then plus and minus. But the important thing is that if you have things which are at the same level, then you go from left to right, which is the example that we've seen. Greatest? What is the greatest integer function? I don't know the greatest. I don't know what is the greatest integer function. Other questions? Is there anyone who has not filled up the attendance? You have not filled the biometric? Okay, if there are no other questions, thank you. We'll meet in the labs for some set of sections, and the others we'll meet tomorrow. Thank you.